This unit will be solving systems of equations using various methods. The first one that we're going to focus on is the substitution method. Before that, let's define a few things. A system of equations. A system is something in which the different parts contained within it are working together to find a solution, solve something. So a system of linear means straight lines, equations means I'm going to have multiple straight lines all on the same graph. Let's start with two of them, and they're going to intersect at some point. I want to find that intersection. Now I should clarify. Two lines on a graph should intersect at some point unless they are exactly parallel to one another, in which case there's no solution. But other than that one case, you will find a solution somewhere. Today we'll be working on this in using the substitution method, which means that I'm going to be replacing something. I'm going to solve for one variable in one of the equations, and I'll be substituting or replacing what I find into the other equation. Let's begin with the first example. Y minus 1 equals x minus 5, and my second equation says y equals 2x, which tells me that everywhere in this system, every time I see a y, it is the same as 2x. So I'm going to take this y equals 2x, and I'm going to substitute into the first equation, equation A. So equation A says y minus 1 equals x minus 5. But if y equals 2x, then I can replace this y with 2x and say 2x minus 1 is equal to x minus 5, and then solve for x. Here we'll subtract an x from both sides, and we can actually add 1 to both sides as well. So we'll do all of that at the same time. Two x minus an x is x equals, and then negative 5 plus 1, x is negative 4. Once we've solved one of the variables, I take that and I plug it into an equation in my system. So I can go back to B, and B says y equals 2x. Well, I've just found that x is negative 4. So this is y equals 2 times negative 4. Two times negative 4 is negative 8. So y equals negative 8. So this solution, x equals negative 4 and y equals negative 8, means that without graphing, I know these two equations are going to intersect at the point negative 4, negative 8. Let's try another one. Here I've got these two equations. 3x minus 2y equals 0. And my second one is y plus 1 equals 2x. How this one differs from the first one is that I'm not given automatically x equals this or y equals this. I've got y plus 1 equals 2x, but not just y equals something. So I first have to solve. I have to solve for one of the variables. I pick a variable, I pick one of the equations, and I solve that. There are going to be things that are easier to do. There are things that are going to be harder to do. As you do more of these problems, you'll see and you'll be able to identify which are maybe some of the easier routes to take. So I would start out with equation B, and I see that y plus 1 equals 2x. If I subtract 1 from both sides, that would solve for y. So this will give me y is equal to 2x minus 1. And what I can do with this is I can take this y equals 2x minus 1 and I can substitute into the first equation. So the first equation says 3x minus 2y equals 0. but y is the same as 2x minus 1. So I can say 3x minus 2 times, instead of y, we'll replace that with 2x minus 1. This is equal to 0. And let's distribute here and solve. So I've got 3x, and then minus 4x plus 2 equals 0. 3x minus 4x, so negative x plus 2 equals 0. And here we'll be smart about it. We'll add x to both sides. And we'll get 2 equals x, or x equals 2. And then once I solve for one of the variables, I can go ahead and just plug that in to any equation in this system. It could be my original a, it could be my original b, or it could even be here I found by just moving some things around, y equals 2x minus 1. I think that would be the easiest one to do. We'll say x equals 2, let's plug it in there. Y equals 2 times 2, and then minus 1. So y is going to be 4 minus 1, y is 3. Now there are some real-world applications to this as well. For example, in business, you want to find where the break-even point in your business might be. Let's say that you are selling some product, you're making some product, and then you're selling it. You want to know at what point do your costs equal your revenue so that any sales that you make after that are profit. Here it says the total cost C of producing X units of a product typically has two components, the initial cost and the cost per unit. When enough units have been sold so that the total revenue R equals the total cost C, the sales are said to have reached the break-even point. You will find that the break-even point corresponds to the point of intersection of the cost and revenue curves. Here's an example of that. A small business invests $10,000 in equipment, so that's their initial cost. They have to pay $10,000 up front to produce a new soft drink. Each bottle of the soft drink costs 65 cents to produce, and it sells for $1.20. How many bottles must be sold before the business breaks even? So up until that point, the business is in debt. It owes money, or it at least has more cost than it's made, so it hasn't made any money yet. We have to find two equations. What's the total cost and what's the total revenue? Well, the total cost is the cost per bottle times the number of bottles that you make, plus whatever initial cost you had. $10,000 was my initial cost, so I know this last part, plus 10,000. The cost per bottle, it's 65 cents per bottle, and I don't know how many bottles I'm going to have to make yet, or how many bottles I am going to make, so I'm just going to use that as variable X. My cost is going to be 0.65X plus 10,000. My revenue, well, that's just how many bottles I sell times $1.20. So price per bottle times the number of bottles, 1.20, and then we used X for number of bottles here, so I'm going to use X here as well. The break-even point is when these two things are exactly the same. At what point does my cost equal my revenue so that any bottle sold after that is profit? Well, here's what we would do. I did make a graph of this. Here we've got the cost, and here we've got the revenue. And the intersection, I could find this graphically, or I could use the substitution method, as I've done here, to find that I would need to sell 18,282 bottles in order to reach the break-even point. Any number of bottles less than this, I would be using more money than I would be making from this business. So that's not good. And any number of bottles I sell after this point is profit. So that's one example of how to use systems. We'll be looking at a few more in the coming sections and lessons after this.